solve, write the solution set using interval notation. The absolute value of 2x minus 5 is less than or equal to 7, and the absolute value of x minus 2 is greater than or equal to 2. Before we start, notice the word and. That means that whatever values are solutions, they must be solutions of this and this. So we will be looking at intersections of solution sets. Let's start with this. When we have the absolute value of an expression less than or equal to a number, we can write that as negative 7 is less than or equal to 2x minus 5, and 2x minus 5 also must be less than or equal to positive 7. Adding 5 on both sides, we have negative 2 is less than or equal to 2x, and that is less than or equal to 12. And dividing everything by 2, we have negative 1 is less than or equal to x, which is less than or equal to 6. So the interval from negative 1 to 6 is the solution set of this first inequality. Now let's look at the second inequality. In order for this to be true, this is actually going to translate to a disjunction. We have to have x minus 2 must be less than or equal to negative 2, or x minus 2 must be greater than or equal to 2. Well, here we would have x is less than or equal to 0, or x is greater than or equal to 4. So we actually have this, and this has an or in it. But let's just take one part at a time. First of all, let's graph the solution set of this. This is the interval from negative 1 to 6. So we will graph the interval from negative 1 to 6, and notice that it includes the negative 1 and the 6. So I'll just highlight that section on this number line. And then on a separate number line that's aligned with the first one, let's graph the solution set of the second absolute value inequality. We have that x must be less than or equal to 0 or greater than or equal to 4. Those two intervals can be graphed this way, less than or equal to 0 or greater than or equal to 4. Now we have the two separate parts graphed, so now we can take care of the and in the middle. The and in the middle says we're looking for the intersection of these graphs. So if we look straight down, the things that are covered by both of those graphs, first of all, we see the interval between negative 1 and 0 is overlapped by these graphs. So that will be part of the solution set. Numbers between negative 1 and 0 will make both of those inequalities true. And then we go ahead to the next section that's overlapped, and between 4 and 6, we see that that is also part of the intersection of the solution sets. So we shade that in as well. And those two intervals on the number line are the only places where these two solution sets overlap. So we can say that the solution would be, in interval notation, the interval from negative 1 to 0 union the interval from 4 to 6.